$2.6 billion. That is the value of mayonnaise sales in the US in just a single year. This staggering figure has propelled the white condiment past ketchup to become the best-selling condiment in the country. To produce such vast quantities of mayonnaise, ingredients like eggs, oil, and vinegar are processed on high-speed production lines at facilities such as Hellmann's. But the most fascinating part happens before the mayonnaise even makes it into the jar. Oil and water naturally do not mix. So, how do factories transform them into a blend that is up to 80% oil, yet remains thick, smooth, uniform, and stable for months? Today, join Mido Explained as we step inside one of America's largest mayonnaise factories to explore the entire production process. Mayonnaise has actually existed for centuries, with one of the most famous theories tracing the sauce's origins to the Spanish port city of Mahon in 1756. However, more than a century later, the story of mayonnaise in the United States began in a small New York deli. Richard Hellmann, a German immigrant, sold mayonnaise made using his wife Margaret's recipe alongside other deli items. Customers loved it so much that the mayonnaise eventually became a standalone product rather than just an accompanying condiment. Initially, Hellmann sold two different versions. To distinguish between them, he tied a blue ribbon around the more popular one. That small detail later evolved into the famous blue ribbon symbol associated with the Hellmann's brand. Demand grew so rapidly that the recipe, once prepared in a small kitchen, eventually moved to a factory for industrial-scale production. The journey from a handmade recipe in a small kitchen to millions of jars rolling off modern production lines begins with the same three fundamental ingredients: eggs, oil, and vinegar. However, industrial mayonnaise production does not involve workers cracking individual eggs as one would at home. At the supplier's facility, thousands of eggs are continuously fed into automated cracking machines. The shells are separated, and the liquid egg content is collected and passed through a filtration system to remove any remaining shell fragments or impurities. The liquid egg then undergoes controlled heat pasteurization, sufficient to reduce pathogenic bacteria like salmonella, without causing the egg to coagulate. At Hellmann's, each delivery truck can carry approximately 48,000 pounds of liquid egg. The tanker valves are sealed by the supplier at the point of origin to prevent tampering during transit. The second key ingredient, soybean oil, which typically makes up about 80% of the mayonnaise recipe, arrives via rail tanker cars. This massive volume of oil is also sealed until it reaches the factory gate, where it is pumped into a dedicated storage tank system. Finally, there is vinegar. Although it constitutes a much smaller proportion of the recipe than the oil, it provides the signature tangy flavor and creates an acidic environment that helps inhibit the growth of various microorganisms. Before the eggs and oil meet, the factory prepares an intermediate mixture known as a slurry. Hellmann's secret blend of seasonings is precisely weighed and mixed with white vinegar, apple cider vinegar, and salt. Liquid natural flavorings are then added, and the entire mixture is blended into a tank of room-temperature water. At this stage, 3 ingredient tanks stand ready: the slurry tank, a tank of chilled liquid eggs, and a tank of soybean oil. A computer-controlled metering system draws the exact required amount from each tank and feeds them all into a central mixing vessel. On an industrial scale, modern mayonnaise emulsification lines can process up to 13,000 pounds per hour. Oil is pumped in at a strictly controlled rate, allowing the high-intensity shearing system sufficient time to break down oil droplets to a size of just a few microns. dozens of times smaller than a human hair. After just a few minutes of high-intensity mixing, the three separate ingredient streams merge into a uniform, homogeneous product. A smooth, creamy mayonnaise with a subtle tang that shows no signs of separating. During production, the factory periodically collects mayonnaise samples and sends them to the quality control department. Technicians inspect the color, flavor, and consistency, while also measuring acidity levels using phenolphthalein and deionized water. Only batches that meet the standards are permitted to proceed to the packaging line. The process begins with jar feeding. Thousands of empty polyethylene jars are placed onto a conveyor system where they are automatically oriented correctly and spaced evenly before entering the filling machine. Next comes the filling stage, a process far more complex than filling containers with liquids like water or soft drinks. Because mayonnaise is thick and highly viscous, the system must generate sufficient pressure to rapidly force the sauce through the filling nozzle, while precisely metering the amount for each jar. The flow must also be controlled to minimize air entrapment, which creates internal air pockets, and to prevent the sauce from smearing onto the jar's rim. Once the preset volume is reached, the flow is cut off sharply to minimize dripping onto the conveyor belt. The entire filling cycle for a single jar takes approximately a quarter of a second. In rotary-style machines, multiple filling stations operate continuously as the jars move in a circle, eliminating the need to pause the process between individual units. The filled jars are then transferred directly to the capping machine. Caps are automatically oriented, placed onto the jars, and tightened with controlled force to ensure a secure seal without damaging the threads. Subsequently, each jar undergoes labeling, batch code printing, and a fill level check. Substandard products are removed from the line before the remaining jars are boxed, palletized, and transported to the distribution warehouse. If you had to guess, how long do you think an unopened jar of mayonnaise can sit on a shelf and remain safe to eat? Drop your guess in the comments section. A natural question many people have is this: how can a product containing eggs sit on a supermarket shelf for months without refrigeration and still remain safe? The answer lies in 3 layers of protection, and none of them works alone. The first begins with the ingredients. The liquid eggs are pasteurized before entering production, significantly reducing the risk from harmful bacteria such as salmonella. The second layer is built into the recipe itself. Thanks to the vinegar in the slurry, mayonnaise is highly acidic, creating an environment where many microorganisms struggle to grow. This includes Clostridium botulinum spores. The acid does not destroy these spores, but it helps prevent them from germinating and growing. The third layer is the closed production process, from acidity testing in the quality control lab to the aluminum foil seal applied immediately after filling. As long as that seal remains intact, the mayonnaise stays largely isolated from the outside environment. But the mayonnaise coming off production lines today no longer comes in just one flavor. Hellmann's has expanded its range with varieties like chipotle, garlic aioli, and chili lime, targeting younger consumers who are increasingly drawn to bolder, spicier, and more globally inspired flavors. According to Unilever, sales of flavored mayonnaise nearly doubled in just 1 year. Surprisingly, these new varieties haven't cannibalized sales of Hellmann's real mayonnaise. Instead, as many as 70% of consumers who buy a flavored mayonnaise also purchase a jar of the original. For the factory, that means the same emulsion base we've followed throughout this video must now serve as the foundation for an expanding range of recipes. Yet every variation still has to meet the same requirements for acidity, stability, and quality control that we saw in the earlier stages. Have you ever tried a flavored mayonnaise? Let us know in the comments. The same emulsification principle we've followed throughout this video can produce completely different results in the hands of different manufacturers. In Japan, Kewpie Mayonnaise was launched in 1925 after its founder, Toichiro Nakashima, discovered mayonnaise during a trip to the United States. Instead of using whole eggs, he used only egg yolks and replaced distilled vinegar with rice vinegar diluted to exactly 10% acidity, creating a richer mayonnaise with a much stronger umami flavor than its American counterpart. The main differences between the two recipes lie in the eggs, vinegar, and seasonings, rather than in the fundamental production process. Today, Japanese mayonnaise has become a familiar addition to foods like takoyaki, okonomiyaki, and Japanese-style sandwiches. What's interesting is that the technology behind them speaks almost the same language. Control the ingredients, create a stable emulsion, adjust the acidity, and maintain the right consistency. Yet simply changing the eggs, vinegar, and seasonings can turn the same basic manufacturing process into mayonnaise with a completely different flavor. Returning to our opening question, how can oil and water stay mixed for months? The answer lies in carefully controlled ingredients, emulsification, and production. So the next time you open a jar of mayonnaise, remember, it's more than just a sauce. It's chemistry being repeated millions of times every day. If you enjoyed this video, hit like, leave a comment, and subscribe to Mido Explained for more fascinating manufacturing stories. See you in the next one.